All right, AP Statistics, welcome to your first video lesson. It's all about flamingos, not. Okay, this is just our intro lesson. So this is going to get us familiar with using some vocabulary that we have, and also it's going to get us used to looking at data in the way that we're going to look at it in AP Statistics. All right, so when we're analyzing data, we're going to look at a group of individuals, right? Objects described by a set of data. So these aren't always people, right? These individuals could be mice. It could be plots of land. It could be trees. It could be just about anything. We can find out information about them, right? So we can assign some sort of a variable. Those variables are either going to be categorical or quantitative. A categorical variable is something like red, or all the things that are red, or all of the things that are boys, all of the things that are girls, things like that, right? Things that can't be quantified. They're not assigned some sort of a numerical value. A quantitative variable is just that, right? It takes on a numerical value. How many things are red, right? How old is each boy? How old is each girl? How tall is a tree? Those kinds of things. All right, of course, a variable is going to take on many different values, right? It's kind of what variables do, isn't it? So we are also going to be interested in how often a variable takes on each value. That'll help us develop some proportions and things like that. That'll be really important for us to calculate probabilities and do some sort of inference on in the future. And we'll talk more about inference here in just a minute. All right, so the distribution is kind of, in a nutshell, what all of these values of variables looks like, right? So you can take these variables, right? These are gas mileage for different cars, right? So our variable then is our miles per gallon. And we have, each car has different miles per gallon. If we look at the distribution of that variable, miles per gallon, you can see it from this dot plot, right? It's a dot plot of mile per gallon distribution. So that's the most simple way that we'll be organizing data. We'll be looking at a dot plot of that data. We can also turn that into what's called a histogram. We'll talk about that in an upcoming lesson. All right, so when we're exploring data, we're always going to start with a graph. That's going to be the way to go. You want to try to look at a graph of these values, and when we get our calculators, we're going to be able to produce this graph really easily. And then after that, once we have this data in such a way that we can look at a graph, we'll be able to also look at some numerical summaries. In here where it says bar stats, we have a few different things in there. X bar, it turns out, is our mean, and that is 27. Sum of all of our x values, that's the sum of all of our variable values. And we'll get into what all of these symbols and things mean later on as we go into class, right? We're just doing intro at this point. But we love looking at a graph of the data because it gives us an overview, and we can actually say a bit about the data based on the graph, right? For instance, it looks like most of the miles per gallon that these cars are getting is on the higher side, right? It seems like at 22 it drops off, right? So it's kind of, all the data seems to be shifted in the direction of 34 in higher values. All right, so when we collect data, we're going to have a population that we want to find something out about, right? We're going to take a sample from that population, right? For instance, with the example of the cars. We don't have a list of every single car that was ever made and the miles per gallon. We don't have that comprehensive of a list. What we have is a sample of different cars that have different values or variable values for miles per gallon. We need to make sure that we're collecting data from a representative sample, right? If we're collecting data about cars and miles per gallon of cars, we're not going to throw a tractor in. Right? We're not going to look at backhoes. We're not going to look at trains. It wouldn't make any sense because those wouldn't be a representative sample if we're trying to find information out about cars. Then we're going to make an inference about that population, right? So we're gonna say something about what we think this data is telling us about the entire population of cars, right? An inference is almost like making a prediction, but we don't ever want to say things are cut and dry in statistics. We make a prediction or we infer something, right? We don't say it's going to rain tomorrow. We say there's a 70% chance of rain tomorrow. Because we can't make predictions that we know are absolutely, definitely going to happen just because of the way that probability works. And we'll get into that a lot more when we talk about probability. All right, so that's really it for our mini lesson. You can have a look at our assignment that we're going to work on in class tomorrow. And that is going to be page 6, 1 through 6. We'll probably be able to get that done very quickly. So thank you so much for watching. And I hope you're having a great evening. See you tomorrow.